Hi, everyone. I'm Pallavi Deshpande. I'm a technology leader with over 2 decades of experience. I've been a developer and done various roles in the tech, done the leadership roles as well. So this topic is very interesting as we are in the AI era, and a lot of AI assistants are evolving. And I have been an AI champion myself, where we have made sure the teams adopt the tools of AI assistants. GitHub Copilot, yes, guys, come on, experiment it. Let's see how it works. What are the strengths, weakness, etc. So this is very important because we are getting into the details. The devil is in the details, as we see. So my intention here is to make sure we understand the risks versus what we have with the AI hype, and take the right decisions accordingly as a developer, AI engineer, as well as tech leaders as well. So maybe let me just do a quick check. How many of you are developers or AI engineers out here? Please raise your hand. All right. How many are tech leaders or C-level? Yeah, okay. We got a mixture of both, which is good. I will try to be, simplistic because the topic is a little tech heavy, but however, it is more from a tech leader's perspective than the AI engineers or developer's perspective, but I'll try to touch on that. Other couple of disclaimers here. I'm not here to advertise or sponsor and talk about the companies and the tools which I'm going to talk about later in the slide. So I'm just talking about my experience, my research, and everything, the data, what you see is coming from the research here. Yeah. All right, so AI coding assistants, are they going to be creating a tech debt factory, or it's going to be our friend? So let's see that. Okay, what is technical debt? I'm sure you have heard about it. It's the shortcuts the developers take in terms of moving the deadlines to meet the delivery deadlines and push it to production. Yeah, we all know that. There are various types of technical debt. I'm here focused on only 4 types. The code level debt, which is again, obviously you have too much to do, too many deliverables, too many features, but you got to get it into the production environment. So the shortcuts taken by the development team. The second is the design debt, which is again a poor decision designs made by the product management team because something is not available. Unfortunately, it doesn't get documented most of the times, but it does. That's a good practice. The third one here is the architecture debt, which is, again, a lot of tactical decisions are taken to make sure we meet that. For instance, something is not available at the organization level, enterprise level, we take a shortcut, but it gets documented in some organizations. It doesn't get documented in some organizations. So that's the architecture technical debt. The last one is the infrastructure. We are all moving from the legacy applications to the modern world in the cloud, microservices, etc. We must have done certain things in the VPC. It's need to be moved to the new VPC, or there are things which is systems are legacy, end of life, end of support, etc. Those systems. So all that is part of the infrastructure part of it. All right. The promise here is the speed. We love using the tools. Everyone, I think we talked about earlier in the sessions, people who are taking using a lot of AI tools there for their productivity day in, day out. Yes, we want to be up to date. We want to get that speed. We want to reduce those repetitive tasks. However, at the risk of high unmaintainable code there. So what do I mean by that? I'll go into details. The gravity of the problem here, what we have is being explained here in the data. So this is based on the research done. There is nothing I have hooked up here. It's all based on the research done. I've given the links over here from some of the universities and the companies. There was a study done about the manual, the code written by the human written code versus the various tools out here. So the code correctness versus the average code correctness of these tools. If you see from GitHub Copilot, the previous version, so all these studies are being done from 2022, 23, 24 until 25. So that's the data what we are talking about. Yeah. So it's around 50% correct which is alarming actually, yeah? And if you see the proportion of that is again incorrect code and then partially correct, and it's only 50%. So there's a little narrow down about the GitHub Copilot specifically there. There's a CSS score, which is the code correction score there, which is also scary to look at. The third table, if you look at it, this is all about some 6 LLMs were researched in terms of the codes that is being produced with the KLOC, the complexity. But if you see the numbers, the code smells are more than 90% of code smells, which is dangerous, isn't it? Yeah, and if you see the last table down there, which is why these code smells are coming, it's because of those security-related issues, quality-related issues, etc., which is a big problem. Yeah, we'll see further the gravity of the problem with some more data with the empirical evaluation here of AI code generators, with ChatGPT producing only 65% correct code, yeah? Versus, again, Amber is partially correct, Red is all incorrect code. And GitHub Copilot, Amazon Code Whisperer. So this is the data which is telling us why we need human intelligence and some tools in place to mitigate it, right? All right, that's the problem in hand. What actually the data shows versus the productivity and adoption. Studies say that 55% is faster task completion with these tools. Excellent, fantastic. Yes, we all need to embrace that. Developers also say, they accept, yes, there is a productivity gain and they're adopting it, which is fantastic. However, the Forrester report says 75% of the leaders are actually, worried about the tech debt rise in 2026. That's the prediction. So this is the existing in terms of the productivity, adoption, but also prediction, which is really significant. All right, what are the hidden risks and how these show up in terms of your code? They will show up in security, yeah, in terms of the prompt injection, IO failure. They will show up in terms of your quality of your code. It will have a really impact on the maintainability part of it, scalability, and flexibility. So we have all seen, we all know that the software engineering is complex, complicated. Yeah, we have seen the evolution of software engineers as well. We have seen the front-end, back-end developers. We have seen, full-stack developers. Now we see all AI engineers. People are talking about we don't need software engineers anymore. We need all AI engineers. Yeah, really? Okay. What are the different tools available in the market? As I said, I'm not sponsoring and telling about, use this tool, but here are some tools available in the market in terms of, the framework and what it does well and what are the key features there. So I've listed CodeScene, Endepend, Arcane, StepSide, and other tools which are really fantastic. I was looking at Arcane tool specifically. This is fantastic with respect to what it does from an architecture perspective, what it provides the data to say, in a visual way from a reporting perspective. So I worked with one of the teams to really identify what is the technical debt, the awareness part of it, identifying it, and measuring it through the story points, putting it all that in Jira, and ensuring it's being tracked, made visible at the dashboard level. So that's exactly done in that Arcane tool, which is visually available with the data and dashboards. That's something which we all need in the teams from an engineering perspective. All right, moving on, other tools available. Again, Anthropic, Rebelia, AI, Lakira. So these are really fantastic, but again, you cannot use all of them depending on what is the context, what is the need, and what is that best you need to do. So anyone have heard about Jailbreak? Jailbreak, yeah, we know about the Jailbreak. It is hacking the AI model, how we have to have the defense against that. Again, it all comes through the tool, so we need to ensure it's taken care, but it is the human intelligence which is really important. And we can't just say whatever AI-generated tools comes in, we can't consume as is. Put your perspective, put your human intelligence in loop to ensure that you make best use of the AI hype. Yeah. All right, I have put together some do's and don'ts in terms of your engineering teams. What are the good practices here? Make your code health as a KPI, key performance indicator, because if your team doesn't know what it is, if they don't address this, you can't actually track and measure it. Yeah, so make sure that becomes your KPI, and don't accept whatever the AI-generated tools are telling you. And if you see, there was a study done recently which said, yes, AI code-generated tools are all excellent, but they work excellent for only when you're doing the first time the code, right? How many of the organizations are like in terms of they write only the code first? Yeah, there was a study which said it's only around 15% of the percentage of developers use for anything new, yeah, from the scratch, yeah? The other rest of the 85% is all about understanding the existing code and then putting your intelligence into the picture. Yeah, so that's where the complexity comes in. Do optimize for, like as I said, understand the existing code than just merely writing it. Just don't focus on just the speed there. Conduct continuous code inspections, which is really key, and do focus on the refactoring efforts in terms of your hotspots, and don't attempt to fix all your technical debt. So I worked with my engineering team to ensure we had created a kind of a security gate. So any release, so it's a release metric, like any release to go to the production, we need to make sure that has been set in terms of the quality gates. Yeah, so you can't actually fix all the code smells or vulnerabilities there. You can only fix the critical, high, medium, and not the low part of it. Yeah, I'm not going to read all of this, but this is to ensure some good practices happen in your organizations. Practical mitigation strategy, review, and make sure the human loop is in there, in between to ensure you take care of the security part of it. Yeah. CI gates, AI linting, labeling, and especially the prompt guide. So there has been a study which says if you use the prompt guide, it will help you to reduce 30 to 40% of the fewer rework cycles when it comes to the AI-assisted tools. So the bottom line here is trust the AI tools, but verify with your human intelligence in place. Yeah? All right, what's next? Next, maybe the self-diagnostic AI are coming already as we speak now. We don't know. But the governance of AI Copilot is a shared responsibility. It is not the responsibility of just a software engineer or an AI engineer. It is the responsibility of a tech leader as well, who can actually understand what is the problem we are trying to solve. Yeah? Make sure you create that environment which is really helpful for the team to make sure we work, take the AI as our companion, yeah, and augment with your human intelligence. So let AI assist, not insist. Otherwise, you will end up creating the tech debt factory. So it depends on us, and it is, for us to ensure how we create that environment for the team to make it as really a good friend when it comes to the AI tools. So that's what I want to conclude. I know this is a very technical, heavy topic, and I'm open for any questions if you have later point of time. So thank you so much, and I'm being consistent here in showing up all the QR codes. So yeah, you can connect me later on LinkedIn, and thank you for listening. Thank you.